Assalamualaikum everyone. In the last class, we have discussed about the logarithmic and exponential function. So, how we can use this function. And now in today's class, I will how we have to use the logarithmic and the exponential function to find the complicated calculation. So now in the today's class, we will discuss about how to differentiate the given functions, given exponential functions. Now further we will go for how to differentiate for the logarithmic function. But in today's class, we will discuss about how to differentiate the exponential function. So here the question is given to you, differentiate the following with respect to x, e raised to x divided by sin x is our first question. Now take solution of first one. So what is given to you? Now first we have to consider like y is equal to e raised to x divided by sin of x. E raised to x by sin of x. Here both we are having the function. Here the power is x means algebraic term in terms of algebra. Here we are having x. So these can be differentiated by using the quotient rule. We are having d by dx of u by v. This is the called the quotient rule. Is differentiation of u by v is v square, v into differentiation of u minus u into differentiation of v. This dash denotes differentiation. Okay. So by using this rule, we have to differentiate. So dy by dx is equal to dy by dx is given to you as what is v here? U is e raised to x and v is sin x. So keep v as it is, means sin of x we have to keep this one as it is. Differentiation of u is e raised to x minus keep u as it is. U is x, e raised to x. Differentiation of v means sin x. Sin x differentiation we know that it is cos of x. Okay. Whole divided by v square means sin square of x. Okay. So now we can take e raised to x is common from both. E raised to x into it is sin of x minus cos of x whole divided by sin inverse sin square of x. This is our dy by dx. Just we have applied quotient rule. So we for in the quotient rule, differentiation of u by v is v square into keep v as it is, differentiation of first, and u as it is, differentiation of second one, whole divided by v square. V is here sin x, u is e raised to x. E raised to x differentiation is same e raised to x, and sin x differentiation is cos x. So though after differentiation we got this value e raised to x into sin x minus cos x whole divided by sin inverse of x. This is first the solution for the first question. Now we can further go for second one. Okay, it is very simple. Just if you know this formula, then it is easy for you to differentiate the given function. But the differentiation of sin x is here cos x, and the differentiation of e raised to x, just we have to keep e raised to x as e raised to x. Okay, so this is just first. Okay, now we have to go further. We have to go for, okay, I will drop this and I will show you the second one, solution for the second one. See here in this, now again we have to let y is equal to e raised to power sin x, sin inverse of x. Okay, e raised to power sin inverse of x. So directly we can differentiate, but we have to make some substitution. Sin inverse of x we can have to take t as sin inverse of x. Let t is sin inverse of x. Now dt by dx is differentiation of sin is 1 divided by under root of 1 minus x square. Okay, this is dt by dx. So what about y? Y is equal to, we are taking sin inverse of x as t, so it is e raised to t. Now we are differentiate y with respect to t. dy by dt is e raised to t. Differentiation of e raised to t is as it is. So now we have to find dy by dx. Okay, dy by dx is dy by dt into dt by dx. dy by dt into dt by dx. Okay. So we have dy by dt as e raised to t into dt by dx. We got 1 divided by under root of 1 minus x square. But t, we have made some substitution t as sin inverse of x. So replace t by sin inverse of x is into 1 divided by under root of 1 minus x square. This is the required differentiation of the given y is equal to e raised to sin x. Okay. Here we have made some substitution. What we are taking sin inverse of x by sin inverse of x replacing by t. Then these become y is equal to e raised to t. We are differentiating these two with respect here with respect to x, here with respect to t. Now by substituting these two value by using the chain rule, we got dy by dx as e raised to sin inverse of x into 1 by 1 minus x square under root of 1 minus x square. Okay. Now we will go for the third. This is the solution for the second one. If you want to write, you can write this. So for the solution for the third one is, I will show you the solution for the third is y is equal to, let y is equal to log of cos e raised to x. Okay. Now differentiate directly. We can directly differentiate. Differentiating with respect to x, we get dy by dt dx, dy by dx is equal to log x. Suppose this one has x. Log x differentiation is 1 by x. So x, instead of x we are having cos into e raised to x. Okay. Now we have to differentiate this cos e raised to x by using product rule. Cos e raised to x differentiation is just no need to apply product rule, because for the angle of cos we are having e raised to x. So suppose this one has only one function, cos of x. Okay. Cos x differentiation is minus sin of e raised to x. Now lastly we have to differentiate e raised to x. E raised to x is differentiation is e raised to x. Okay. Don't get confused. Suppose this one has log x. Log x differentiation is 1 over x. So cos x differentiation is minus sin x. Last we have to differentiate e raised to x as e raised to x. Now we can write minus e raised to x. I am taking this minus e raised to x outside. Now what is remaining? Sin of e raised to x divided by cos of e raised to x. So sin by cos we know that it is tan. Minus e raised to x into tan of e raised to x. This is the required dy by dx. Means differentiation of the given function is in this term. In terms of tan, we got sin by cos is tan. So it is very simple. Just don't get confused. Here we are differentiating 3 times. First for log x, second for cos, and third, lastly for e raised to x. Then after substitution, making some substitution, then we got the final answer. Okay. This is the differentiation for exponential function. Now I will show you differentiation for the logarithmic function. How to differentiate logarithmic differentiation, I will show you. Write down logarithmic differentiation. Logarithmic differentiation. In the logarithmic differentiation, we will see how we can use log to differentiate a function. So logarithmic differentiation, it does not mean how to differentiate the logarithmic function. It means how we can use log to differentiate the given function. If we are having some terms, we are having completed function, So we can be differentiate by using log. Okay. So we know that in this section we will learn how to differentiate. Consider a function we are having y as f of x. Y is equal to f of x is equal to u of x raised to the power v of x. Suppose we are having system a function. Now, if we want to differentiate this function, simply directly we can't differentiate this because here we are having one function and power is also having one another function. So directly we can't differentiate. So we are taking some substitution. How? Taking log on both sides. Log on both sides. Log of y is equal to log of u of x raised to the power v of x. But we know that one property of log as log of p raised to n base is equal to n log of p to the base b. This is one property of log. By using this property here, we will get log of y is equal to v of x into log of u of x. Okay. Now it is simply we can differentiate. Differentiating both sides with respect to x. Differentiating with respect to x, we get here log y differentiation is 1 by y dy by dx. Okay. Now differentiation here we have to apply product rule. V of x, keep this one as it is. Differentiation of 1 log x is 1 by u of x. Suppose this is x. Log x differentiation is 1 by x into u dash of x. Okay, plus keep this as it is log of u of x into differentiation of v of x as v dash of x. Okay. So now we have to find dy by dx. Dy by dx is here. I am taking this y here. Then it goes into multiplication form. V of x by u of x into u dash of x plus v dash of x into log of u of x. So if we are having this type of function, so to differentiate such type of function, we are taking log on both sides. After taking log, we can easily differentiate. So in this section, we will discuss how we can use log to differentiate the functions. Okay. So after taking log, we are applying here product rule u into v. These keep this one as it is, differentiation of this log x, suppose with this, then keep this second term as it is, differentiation of first. Now differentiation of log y is 1 by y. So this y, it goes into numerator, all in the multiplication. Then y is equal to u of x. Now lastly we have to write down the value of y. Y we are having u of x raised to the power v of x. Okay. Y is u of x raised to the power v of x. Okay. Into this whole bracket, v of x divided by u of x into u dash of x. Don't get confused. This one is u plus v dash of x into log of u of x. This is the final required differentiation of the given function. Okay. By using the same procedure, by using the same method, I will show you some example. This is just for general. It is for general understanding purpose. I will show you some example. Then easily you can understand. Write down example. Write down the example. Differentiate the function. Differentiate the function the function with respect to x. The first question is cos x into cos 2x into cos 3x. Second one is x raised to sine inverse of x, where x is greater than 0. And the third one is differentiate with respect to x. So, x minus 3, x square plus 4 whole divided by 3x square plus 4x plus 5. So here we are having three questions. I will show you the solution of this one by one. So first take solution for first one. Solution for the first one. Let y is equal to what is given to you, cos x into cos 2x into cos 3x. Here all these, here we are having cos, but these three cos in terms of multiplication, both all these three cos terms we are having. If it is given to you in the addition on the subtraction form, then you can easily differentiate it, but it is in the form of multiplication. So these three are multiplied to each other. So for this, how to find the differentiation? First, we are taking log on both sides. Okay, taking log on both sides. BVS is for both sides. So log of y is equal to log of right cos x into cos 2x into cos 3x. So we know that one property of cos log as log of PQ. If you are having to the base b, we can write this one as, if p and q are in the form of multiplication, we can write log p to the base b plus log of q if you are having. So same property we have to apply here, then it becomes log of cos x plus log of cos 2x plus log of cos 2x, log of cos 3x. So here it is log of y. After applying log, we can easily differentiate. Differentiating with respect to x. Differentiating with respect to x, we will get log y differentiation is 1 by y divided by dx. 1 by y divided by dx is equal to, here we are having log of x, log of cos x. Log cos x, suppose this one as x. So log x is, we know that it is 1 by x. But here instead of x we are having cos x. So write log cos x differentiation 1 by x. What is the differentiation of cos x? Cos x differentiation is minus sin x. So then don't get confused here. Log of x we are having. So consider this function, this whole function cos x as x. Log x differentiation is 1 by x. We know that. Okay. And what about, again we have to differentiate cos x. Cos x differentiation is minus sin x. Similarly, we are using 1 by cos 2x differentiation of log x. Okay. Into differentiation of cos is cos of minus sin 2x. Sorry, 2 minus sin 2x. Plus lastly 1 by cos of 3x into minus 3 cos 3x differentiation is minus 3 sin 3x. Okay, so here we can write minus of sin by cos is tan of x. Here it is minus 2 sin by cos, sin 2x by cos 2x is tan by tan 2x, minus 3, just for your understanding I am writing sin of 3x by cos 3x. Okay, here also I will write sin of 2x by cos 2x. So sine by cos is tan, so we know that we can write. And this y, what about this y? 1 by y we are adding. I am taking this y on the right side. Here, if this y is in the denominator. If I am taking this by cross multiplication, it goes in the numerator like this. Okay, y minus of tan x minus 2 tan of 2x minus 3 tan of 3x. So I am taking minus sign common, minus y tan of x plus 2 tan 2x plus 3 tan 3x. Okay. So what about y? Y we are having cos x, cos 2x, cos 3x. So write down minus of cos x cos 2x into cos 3x into this whole bracket, tan x plus 2 tan 2x plus 3 tan 3x. With this is the required differentiation of the given problem. Okay. After applying log, we can easily differentiate. So here, that's why we are applying log to both the side. We have to apply log on both the side. Then we have to differentiate. And remember this. The differentiation of log y is 1 by y into dy by dx. Then after in the last step, we have to take this y on the right hand side. Then substitute the value of given y value. Okay. So this is the solution for first. Now we will go for the solution for the second one. If you want, you can take write down. So now write the solution for the second one is this is the solution for second one. Let y is equal to x sine of x sine of x is given to you. So now directly we can't differentiate, so I am applying taking log on both sides. Taking log on both sides. Log of y is equal to sine of x into log x. Okay. So log y is equal to sine x into log x. Now we can differentiate. Differentiating with respect to it. Differentiating 1 by y dy by dx is equal to, by using product rule, sin x as it is, sin x as it is, differentiation of log x is 1 by x plus log x as it is, differentiation by using product rule, sin x as it is, differentiation of log x is 1 by x plus log x keep as it is, differentiation of sin is cos x. Okay, so here we are having y, we have to take this y on the right hand side, then it goes into numerator as y is equal to sine of x divided by x plus cos x into log of x. Substitute the value of y value, x sine of x into sine x by x plus cos x into log of x. So now we can further simplify as keep sin x as it is. I am taking this x on the numerator, then it will become x raised to minus 1. So sine of x into sine of minus 1. Okay, sorry, x raised to minus 1 plus x sine of x into cos of x into log of x. So sine of x into x raised to sine of x minus 1, x raised to sine of x minus 1 plus x raised to sine of x into cos of x log x. This is the required differentiation of the given equation. x is to sin x differentiation is this. After applying log, we can easily differentiate. But remember this, differentiation of log x is 1 by y. In the last step, we have to take this y on the right hand side, then it goes into numerator. So now finally we have to substitute the y value. After substituting y value, we can further simplify, then we will get the required answer. Now go for the third one. Write down third question. Solution for the third one. Let y is equal to third one. The solution for third one is let y is equal to under root of x minus 3 into x square plus 4 whole divided by 3x square plus 4x plus 5. Now solution for third one. Okay. So taking log on both sides. Taking log on both sides, we get log of y is equal to log of this root we can write in the form of power as x minus 3 x square plus 4 whole divided by 3x square plus 4x plus 5. So root we can write root as square root as power 1 by 2. So we know that by log property we can take this 1 by 2 in the product form or the multiplication 1 by 2 of log x minus 3 x square by 4 whole divided by 3x square plus 4x plus 5. Further we can simplify by 1 by 2 as it is log of x minus 3 into x square plus means we can write log x minus 3 plus log x square plus 4. Log x minus 3 plus log x square plus 4. This is in the common denominator. So we have to write this one as log minus of log 3x square plus 4x plus 5. Okay. Now we can differentiate easily. Log of y. Differentiating with respect to x. Differentiating with respect to x. How we have to write this? By using the log property. Log of mn is log m plus log n. So log p by q if you are having log of p minus log of q. So this if you are having in the division form we have to take minus along with the denominator term. Okay. So log y differentiation is 1 by y dy by dx is equal to 1 by 2 as it is. Log x minus 3 differentiation is 1 by x minus 3 plus log x square plus 2 differentiation is 1 by x square plus 4. Again we have to differentiate x square. X square differentiation is 2x minus log 3x square plus 4x plus 5 is 1 divided by 3x square plus 4x plus 5. We have to again differentiate this bracket. It is 3x square is 6x. Differentiation of 3x square 6x. 4x is 4. Differentiation of 5 is 0. Okay. So now dy by dx is equal to, I am taking this y, then it goes into numerator. 1 by 2 keep as it is, y into 1 by x minus 3 plus 2x by x square plus 4 minus 6x plus 4 divided by 3x square plus 4x plus 5. So now we have to substitute the value for y. So dy by dx is equal to, what is y? Y is 1 by 2 under root of x minus 3 into x square plus 4. What is given value? We have to write the value of y as given one. 3x square plus 4x plus 5 into this whole bracket. I am writing this into 1 by x minus 3 plus 2x by x square plus 4 minus 6x plus 4 divided by 3x square plus 4x plus 5. 3x square plus 4x plus 5. This is the required differentiation of the given function. Here we are having a square root. So first we have to take given as y. After this we are taking log on both sides. Log of y is equal to log. If we are applying log, this square root we can write 1 by power in the form of power 1 by 2. So after applying log, we can use log property. We know that log of p raised to n is n p log p. So 1 by 2 it goes into multiplication form, 1 by 2 into log of this whole bracket. Now we can easily differentiate. Again we have to apply log property here. Log of x minus 3 is log, here we are having product p into q. So log p plus log q minus, these we are having in the form of division. So for the denominator we are taking minus sign, minus of log this. After differentiation we got this result, but we know that differentiation of log y is 1 by y. So we are taking this y to right hand side, then it goes into numerator. After in the last step we have to substitute the given value of y, then we will get the required answer. Okay, with this I will stop. I will continue in the next class. Thank you.